In this video, what we're going to do is we're going to move from polar coordinates to rectangular coordinates. Very straightforward, doesn't require too much thinking, but it's useful to get a sense of how to think about it. So let's say that we began with, say, 4 comma 2 pi by 3, and this is given to us in polar coordinates. And we want to shift from that to rectangular. The idea is very straightforward. We start over here, we go up by 2 pi by 3, which does not end up over here. It ends up over there. And we move by a total of 4. So if this is 2 pi by 3, what we can do, the way that this is set up in a lot of engineering examples, is that you look at this and you think about this angle. That's not how you actually calculate it. You calculate it the easy way. But let's see if we can get a proper understanding of what it is that's happening. Let's take this over here. Let's redraw it. And what we're going to do is we're going to try to get a sense of how to move along this line. So I'm going to have this over here. And this time I'm going to use the unit circle. So here's the unit circle. And on the unit circle I've got an angle of 2 pi by 3, which makes this point over here, let's label it right there, cosine of 2 pi by 3, comma, sine of 2 pi by 3 in terms of xy coordinates, right? So in terms of the rectangular coordinates. That gives us what happens when we move one unit in the direction that we want to face. And then instead of moving by 1, we're going to move by a total of 4. So this is just vector multiplication. We're right back to linear algebra territory over here. We take this vector, which is this one over here, and we multiply it by 4. So this point is going to be 4 cosine of 2 pi by 3, comma 4 sine of 2 pi by 3. Again, this is in rectangular coordinates, and so we can translate that. 2 pi by 3, this is going to be negative a half, comma root 3 over 2. So 4 times negative a half, 4 times root 3 over 2. And so our point is going to be negative 2 comma 2 root 3. Right? The idea is that way no matter what. If I wanted to take, say, negative 6 comma negative 3 pi by 2 in polar coordinates, now what I need to do is take the xy plane, look at the unit circle, and if I start over here and move negative 3 pi by 2, this is where I end up. So my cos comma sine is going to be at 0 comma 1 in the x direction, or in the xy coordinates. Now we're facing that way, we're facing straight up, but then we're marking backwards. Our radius is negative 6. And so we're facing that way, but we're going negative 6. That means we take this vector and we multiply it by negative 6 to get something that's a little bit south of the screen. And so what we're going to end up with is that negative 6 comma negative 3 pi by 2 is equal to negative 6 times cosine of minus 3 pi by 2, negative 6 times sine of negative 3 pi by 2 in terms of rectangular coordinates. So this is going to be negative 6 times 1, comma negative 6 times 0, which is negative 6, comma 0. Give or take the fact that I got these two coordinates wrong. So this one over here is a 0, this one over here is a 1, and what we have is, of course, 0 comma negative 6. I wasn't sure how I managed to get an x coordinate of negative 6 on the y-axis. The main idea, the thing that we want to keep in mind is, even though there's a really easy translation, just r cos theta, r sine theta, you plug it in and you're done. It is very important for us to be able to visualize what is happening. That what we're doing is beginning at the origin. We look towards the polar axis and we turn around in the direction that we want, whether it's to the left with positive values of theta or to the right with negative values of theta, or to be very precise, it's always to the left, but it's either by a positive quantity or by a negative quantity until we're facing the correct direction. And then we move either forward or backwards, just using vector multiplication, nothing else, multiplying a vector by a scalar. And that brings us to the point that we want.